SciTrends, I'm Eva Snyder. Okay, so today we're gonna start with this awesome video I found online. Check this out. Those dresses, they're also digital displays, and they can change patterns instantly. And it got me thinking about the way that high tech overlaps with high fashion. Sure, there's already smart watches and smart glasses out there, but what about smart clothing? What would happen if we could take the power of a mobile device and put it into something soft and flexible? To find out, we talked to folks who made those dresses, Francesca Rosella and Ryan Gans. They're with a company called Cute Circuit.
Cute Circuit started in 2004. We were basically the first fashion brand that was entirely focused on creating future fashion.
In other words, they make clothes that have flexible circuits, LED lights, and even tiny computer chips built in.
As a fashion brand, we're really peculiar because, of course, we design fashion, and then we have to also develop technology. So it's very interesting that it's a mix between being an inventor and being a designer.
Francesca and Ryan have created fashions for celebrities like U2 and Katy Perry. They're in high demand because the pieces they make can display almost any pattern, from lines and sparkles to real-time updates from a Twitter feed. It's all controlled from a tiny computer that snaps onto each dress. Cute Circuit calls it a puck.
So the way this was working is my phone is connected wirelessly through Bluetooth to the puck in the garment. Now the puck is like a rechargeable brain, and this has everything you need in it. It has the intelligence, it has the wireless control, and it has the power supply.
That puck can be controlled with a smartphone app, so a few taps of a finger can change the look of your clothes entirely. But there's a catch. You still have to attach batteries and circuit boards onto your clothing. Here at Drexel University in Philadelphia, a team of researchers are trying to fix that problem. Hi, Geneviève, it's so nice to meet you.
Hi, nice to meet you. Welcome to the lab.
Thank you. Geneviève Dion is an industrial designer at Drexel. She and her students are building electronic devices made of fabric.
And what we wanted to do is to think about how can we push the boundaries of textiles by including new and innovative materials into the fabric itself.
They're starting with high-tech yarns that conduct electricity, stuff made of stainless steel, silver-coated nylon, even charcoal. And by knitting those yarns together in different ways, they're able to make a bunch of devices, like antennas, sensors, even fabrics that can store energy. They're called textile supercapacitors. PhD student Christy Jost is designing them.
A supercapacitor is very much like a battery in that you can store energy in it. So you can charge it, just by plugging it in, or you can charge it with solar energy, piezoelectric energy from body movements, body heat, or even Wi-Fi.
How much can this store?
It actually depends on the material you make it out of. Just plain stainless steel yarn, which is what some of these are, essentially it's like powering a phone for just a couple minutes.
Okay.
So not a lot, but if you use materials like activated carbon, you could maybe power your phone for, 10, 20 minutes, up to an hour, up to 2 hours, depending on what you need.
Finding the right materials is only half the battle. To make a textile supercapacitor, you have to put them together in the right way. Even a device this small has 7 different high-tech yarns inside it. Making it by hand would be a big challenge. So instead, Christy uses industrial knitting machines like these. Each one has hundreds of tiny needles inside that loop yarn into complex patterns automatically. It's all controlled by computers. With special 3D software, Christy can program the machines to knit almost anything.
And you can see here that we use the software in order to simulate, there we go, some real garments that incorporate, say, a supercapacitor as well as other circuitry right into the garment.
Designing sensors and supercapacitors is really complex stuff. The software lets Christy plan where every stitch, loop, or knot goes in the final piece. And once that info is sent to the knitting machine, the stuff on the screen becomes a physical object in a matter of minutes. It's almost like printing a piece of clothing. The work that Christy and Geneviève are doing could change the way we think about technology.
It's still a little bit sci-fi, but it's sci-fi really coming to life. And it's happening right now, and it's going to continue to happen in the next 5 to 10 years. It's going to be amazing.
There has been an explosion of wearable tech products recently in what is soon to be a $20 billion industry. To see some of the latest innovations, we came to the Wearable Tech Conference here in San Francisco Bay. So I'm seeing what looks like a lot of futuristic fabrics maybe, and some cool components. Can you tell me what's going on here?
Pretty exciting. It's sort of the technology that enables a lot of the future things that we're doing. And applications are very diverse. Anything from medical to automotive to touchscreen technology and to new fabrics and fibers. Feel this. Give me the back of your hand.
Wow, feels like nothing.
Feels like nothing, right? But what it allows you to do is to add electronics onto fabric and to wearables.
That has electronics in it?
That is actually silver traces that are conductive.
And this could come alive.
Exactly. So you take this material, it's really stretchable, you can pull it. But in order to make it functional, you might need to marry it with a secondary material. So for example, you could put it on some fabric, and here we have a couple different types of fabrics. And now something that just looks like fabric is actually smart on the other side.
This is a technology for inside of a shoe. And what this does is it'll help you understand something called pronation and supination, meaning when you walk, do you walk with your feet kind of in?
I definitely do.
It also counts your steps. It gives you what kind of force. And so if you think about the way this is designed, you want to have that circuit be pliable enough. And so what we do, we take these stretchy type of things with the basic circuit to allow you then to move and keep that durability.
The squiggly kind of allows it to move a lot more.
Yeah.
Hi, I'm Eva. It's nice to meet you.
I'm Winnie.
I'm Winnie. This all looks so cool. I'm really interested about this breast cancer. Can you tell me a little bit more about it?
Yeah, so this is actually a breast cancer detection patch.
Wow.
And it basically is designed to do early detection of breast cancer for women.
Can you tell me a little bit more about how it works?
Yeah, sure. So this is basically a temperature measurement patch
Okay.
that women can wear on their bodies underneath their bra.
Okay.
And it's designed for women who have some questionable mammogram results. So they're waiting for their biopsies, but before they do that, they can do a less invasive measurement by wearing this.
That is so impressive. So what is the benefit of having these LEDs in this clothing?
Imagine a runner that goes out running every day. When they're faced with low light conditions, they actually face a serious threat from vehicles on the road. And so having these illumination really helps athletes, cyclists, low light conditions.
Won't this feel bulky? Won't it?
Not at all.
heavy?
So why don't you have a touch? People don't really feel that they're wearing technology, and yet they are.
Right.
And that's what's really unique. So if you think of a lot of the products that we used to have historically,
Right.
they tended to be really bulky and obtrusive. You wouldn't get sort of the elasticity and flexibility that these products have today.
So where do you think it's going to go from here?
Today, it's really about solving consumer challenges.
Okay.
Tomorrow, it might have applications in aerospace. So the possibilities are really endless.
That's really cool. That's our glimpse into the future of wearable tech. For SciTrends, I'm Eva Snyder.